Welcome to the distance learning program on Android by Innobus. User interface layouts and events. In this chapter, we will be covering the following topics: user interface layout and user interface events. User interface layout. Under this heading, we will see the following topics: creating an activity, creating a service, views and view groups, text manipulation, creating other widgets, and using resources. Creating an activity. The steps involved in creating an activity are as follows. Create a Java class. Make the class a subclass of activity class. Override the onCreate method of the activity class. Load the UI view programmatically or load it from an XML layout. Mention the created activity in the Android manifest.xml file. Now we will see a demo of creating an Android activity. First, we'll create a new Android project. Name the project. Select the build target and name the package. Now we'll open the project. This is the default activity which was created when we created the Android application. We will try creating a new Android activity. So go to the package and create a new class. Name the class. Make sure that the class extends the activity class of the Android package and press finish. The second activity is created. We'll write the onCreate method. This is the method which needs to be overridden to draw the UI to the activity. I'll create a text view object. I'll set some value for the text. And I will set the content of the activity to be the text view. And save the file. These are the simple steps that is required for creating an activity. Here in this case, I have created a text view and set it as the content of the activity. If required, do create the layout in an XML file and mention the ID of the XML layout in the set content view method. Go to the Android manifest file. This contains the activity tag, which indicates the first activity that was generated. Now we will add the activity which we created in the manifest file. Select activity. Select the activity which we created and press OK. Now go back to the XML format of the manifest file and we can see our activity added to the manifest file. Now save the XML file. Creating a service. The steps involved in creating a service are as follows. Create a Java class. Make the class a subclass of service class. Override the onStart command method or the onBind method of the service class. Perform the required operations. Mention the created service in the Android manifest XML file. Now we will see a demo of creating services in Android. For this demo, we will reuse the Android activity demo project which we used it for the previous demo. Open the project, go to the root package and create a new class. Name the service and make sure that the class extends the service class of the Android package. The service is created. Override the onStart command method to perform any operations when the service is started. Similarly, override the onDestroy method to perform operations when you stop the service. If you are going to bind the service with an activity, then add the required code in the onBind method. These are the steps to create a service, but one should remember that the created service must be added to the manifest file. Go to the Android manifest file, click Application, press the Add button and select Service and add the service which we created now. Go to the XML format of the Android manifest file and we can see that the service is added to the Android manifest file. Views and view groups. The topics under this subheading are exploring common views, building layout in Eclipse editor, controlling the width and height of layout elements, setting relative or linear layout and layout ID, declaring a layout programmatically, updating a layout from a separate thread, handling focus, and creating custom views. Exploring common views. The Android platform provides a set of view objects in the Android.view package. These include familiar view objects like edit text, text view, spinner, and button. It also includes specialized widgets like analog clock, time picker, date picker, and gallery. Every view object extends the view base class, so developers would find certain functions common to many widgets. Now let's see a demo of building layout in Eclipse editor. Again, we will reuse the same project which we used for the previous demo. I will open the project, go to the layout file and click on it. The ADT plugin Eclipse makes it easy for editing layouts graphically. There are two tabs at the bottom. The graphical layout shows the graphical UI, whereas the XML format shows the XML content of the layout. A developer can edit the layout manually in the XML file or graphically in the graphical view. Now I will click on the text view which is already present inside the layout and delete it. Any widget can be dragged and dropped from the palette to the layout. Now I have added a edit text box. Similarly, I can add a text view object to the layout, or a button object, checkbox object, or even a spinner object. We can also add layouts within a layout. I add the horizontal linear layout, and now I add multiple buttons inside the horizontal linear layout, so they stack one after the other in a horizontal fashion. Again, if required, the developer can always go to the XML format of the file and edit the properties of the widgets added to the layout file. For instance, if I want to add another button to the layout, I can type the button tag, and it's always mandatory to mention the width and height of the widget that is added. I can also set the text of the button. Now, after saving the XML file, I can go back to the graphical layout and see that the button which I added in the XML format is reflected here. So building layout in Eclipse Editor is very easy because of the drag and drop feature made available by the ADT plugin. Now we will see how to control the width and height of layout elements. First, we will remove the widgets which are already present inside the layout. Now I will add a button to the layout and add another two more buttons. Now I will click on the button to edit its properties. Every widget in a layout requires layout width and layout height property. It can be usually specified in three different ways. One, by exact dimension. For example, 100 SP, or in DP values like 20 DP, or the wrap content value can be used. In that case, the button size would be based on the text size inside the button, and the last value, which is fill parent, makes the widget to fill the screen. Now, having put different values for these three buttons, we will check in the graphical layout how they reflect. The first button, you can see that the width and height are restricted to a particular value, whereas in the second button, the width and height are managed by the text inside the button, whereas in the third button, we can see that irrespective of the size of the text inside the button, the width occupies the full screen, whereas the height is managed by the text inside the button. That's because we have mentioned wrap content for the height of the button. It's usually advised to use wrap content or fill parent than specifying particular values for the width and height of widgets, just because Android runs on multiple devices and the layout needs to look uniform across these devices. We will now see how to set linear layout or relative layout and layout ID for the widgets. The root element of this layout is linear layout and the orientation is vertical. So anything we add to this layout arranges itself as a stack one beneath the other. So now I will add another layout which is a linear layout with horizontal orientation. Again, anything I add to the horizontal linear layout will stack itself against one another in sideways. So irrespective of the device, the widgets arrange themselves one after the another inside the layout and give a common user experience for all the users. Now we will see how to use relative layouts. We will remove the layouts which are present inside this layout. We will go to the XML format of the layout. We will change the root layout to be relative layout. Relative layout allows positioning of the widgets based on the positioning of the neighboring widgets or the parent layouts. For instance, now I'll add a button to the relative layout and I can set the align parent left property to true and align parent top property to true. This makes the button to fit in the top left corner of the layout. Similarly, I can add another button to the bottom right corner by specifying the property align parent right to true and align parent bottom to true. I can also place widgets with respect to the position of the neighboring widgets, like below the first button and parent right to true, or parent left to true and parent bottom to true, and to the left of button 2. And one of the important requirements in relative layout is that every widget needs to have an ID so that positioning can be done based on the ID. So when I dragged and dropped all these widgets, an ID was generated for them automatically. And if required, the ID can be edited and set to any convenient text so that the developer can remember when using them in the activity. It's always advisable that a relative layout is preferred so that the UI becomes uniform across all devices irrespective of their screen resolution and size. Let's now see a demo of declaring a layout programmatically. First, we'll create a new Android project. We'll name the project. Select the build target and name the package. Now we'll open the default activity which was created. We will remove the set content view method which takes the layout from the main.xml file and loads it onto the activity. Now we will create a relative layout object. We will set the layout params of the relative layout. We will set the width and height as fill parent. We will be using this relative layout as the root layout of the activity. Now we will create a new text view object. We will set the text of the text view object. We will set a tag for the text view object. Now we will create another set of relative layout params. This time we will set the layout params as wrap content for both width and height. Now we will add a rule for the new layout param that we created. We will mention the rule as center in parent. Now we'll add the text view to the relative layout. The first parameter is the view, and the second parameter is the layout params which we created just now. So now the text view is added to the root relative layout and it occupies the center position of the layout. Similarly, we will try creating another text view object. This time around we'll set the text as high. We'll also create a new set of relative layout params. Again we'll set the height and width as wrap content. Now we will set the rule for the layout param. We'll mention that this layout should be above the text view which we created initially. And the second parameter is the ID of the text view which we created initially. We will add this text view to the relative layout with the set of layout params which we created now. And finally we'll set the content of the view with the root relative layout and save the file. Now we'll run our application. The activity is launched and we can see that the two text views are added to the layout. The one in the middle is the first text view and the one at the top is the second text view. Thus, a layout can be declared programmatically. Now we will see a demo of updating a layout from a separate thread using handlers and messages. First, we'll create a new Android project and name the project. And select the build target and name the package. Now we'll open the default activity which was created. We will edit the layout file of the activity. We will remove the text which was already present inside the activity. We will add a large text view inside the layout and a button below the text view. We'll save the XML file and return back to the activity. We will create a field for the text view. Inside the onCreate method, we will instantiate the text view object by mapping it to the text view we created in the XML file. We will create a button object and map it with the button we created in the XML file. We will write a on-click listener function for the button. Inside the onClick function, we will call a function doClick. Now we will create the doClick function. Inside the doClick function, we will create a new thread. Inside the run function of the thread, we will create a new text string. We will have an integer variable stating the background color. Now, before further coding the thread, we will create a new handler object. We will also create a new runnable for posting the results to the UI thread. Inside the run function, we'll set the text of the text view which we created. And set the background color. Now going back to the thread in the do-click function, we'll call the post method on the handler object. We will use the update results runnable for that. Then we will call the computation function. We will create the computation function. We will create a for loop. This is just to make sure that the computation takes place for a longer period of time so that the difference in UI can be seen. Then after the computation function in the thread, In order to use the same text string object, we will create the text string as a field. Now we'll copy and paste the code again, but we'll change the text string value. Similarly, we'll create the background color as a field. And set the default color as color dot gray. We will start with the default color. We will change it to red during the second computation period. Similarly, we'll copy and paste the code again for the third time, and we'll change the color to green. Then call the thread.start method. Now run the application. The activity is launched. I click on the button. The color changes to blue and the text changes to first string. Then after a while the color changes to red and the string changes to second string. And finally the color changes to green and the string to third string. Handling focus. The Android framework will handle routine focus movement in response to user input. This includes changing the focus as views are moved or hidden, or as new views becomes available. Views indicate their willingness to take focus through the isFocusable method. To change whether a view can take focus, call setFocusable method. When in touch mode, one can query whether a view allows focus with isFocusable in touch mode method. This can be changed with setFocusable in touch mode method. Focus movement is based on an algorithm which finds the nearest neighbor in a given direction. In certain cases, the default algorithm can be overridden by the developer. To request a particular view to take focus, use the request focus method. To listen for focus events, write a onFocus change listener for the widget. Let's now see a demo of creating custom views in Android. First, we'll create a new Android project. We'll name the project as Custom Text View Demo. We'll select the build target and name the package. And press finish. We will open the project and create a class. I'll name the class as my text view. and make sure that it extends the Android text view and press finish. Now I will add the constructor with the context parameter. I will set the text color to red when I create the object. Color dot red. I'll also set the font size as 16. I'll save the class and go to the demo activity. We will remove the set content view method. We will try to create an instance of the customize widget. We will call the constructor. We will set the text of the text view object. And we will set the content of the view to be the text view object which we created now. And we'll save the activity and run the application. The application is launched and we can see that the text view is added to the layout but with the modified properties. Thus, any view object in Android can be extended and further properties and methods can be added to the object and they can be reused in the application which you develop. Text manipulation. Under this topic, we will see the following headings: setting and changing text attributes, providing text entry, and creating a form. Now let's see a demo of setting and changing text attributes. First, we'll create a new Android project and name the project as text view demo. Select the build target and name the package. And press finish. Now open the project and go to the default activity which was created. We will now edit the layout file of this activity. We will remove this text view which was already present inside the layout and add a bigger text view. And below the text view we'll add another button. And below the text view we'll add a button and change its properties. We'll change the text of the button as change text color. And we'll save the XML file. Now we'll go back to the activity. We will create a text view field. And an array of colors. We'll load the array with 3 colors: blue, red and green. Now inside the onCreate method of the activity, we will instantiate the text view object which we created and map it with the text view which we mentioned in the XML file. We will also create a button object and map it with the button in the XML file. We will write a set onClick listener function for the button. We will also add another field called counter and set its value to 0. Now inside the onClick function of the button, we will set the color of the text view object and pass the parameter as the first item of the array, and we will use the counter. Then we will code such a way that the counter changes its value every time on a button press. Now we'll run our application. The application is launched and we can see the text in the layout and the button. I click on the change text color button and the color of the text changes to blue. The second time I press the button, it changes to red and then to green and then again to blue, and it repeats. Thus, the text attributes of a text view and an edit text can be changed using various methods available for the widget. Let's now see a demo of providing text entry in Android. The edit text class provides a simple view for user input. For this demo, we will reuse the same project which we used for the text view demo. We will go to the text view demo activity and delete the code other than the set content view method. We will also edit the layout file. In the layout file, we will remove the text view and the button which was present inside the layout. In the palette, we will select the text fields option, and there are many types of text fields in Android for the developer to use. All these are edit text widgets with different properties. For example, the first edit text is a text field with plain characters, whereas the second one has a format like first name and last name, and the characters in an edit text can be hidden using the password parameter or a numerical password parameter. The type can be set to email or phone number or even an address box. We'll check the properties in the XML format of the file. We can see that the first edit text is a simple edit text with no additional properties, whereas the second one has an input type called person name, text person name. The next one has an input type as text password, and the following ones have text email address, phone, and text postal address as the parameters for the input type. We will set the hint for each edit text box so that we may know what type of edit text box is the widget. Now we'll run our application to check the different types of edit text boxes. The activity is launched and we can see the different edit text boxes. The first one is a plain text box. The second one is the person name text box, whereas the third one is the password edit text box. And the fourth, fifth, and sixth edit boxes are email, phone, and postal address respectively. Based on the input type of edit text boxes, the keyboard shown will also differ. For instance, when I click on the plain edit text box, a keyboard with all the alphabets and numbers are shown, whereas the phone edit text box shows only numerical buttons. When I click on the password edit text box and I enter characters, they become hidden and are shown as password characters. Thus, different types of edit text boxes can be used to capture user entry. Let's now see a demo of creating a form in Android. First, we'll create a new Android project. Set the project name. Select the build target and name the package. We'll open the default activity which was created and edit its layout file. We'll remove the text view which was already present inside the activity. We'll add a new text view and change its text as name. We will add a text field and next we'll add another label and edit its properties to change its text as email. We will add the email edit text box and then we'll add a button and edit its text to be submit. And we will have a text view below just to test whether we have captured the values correctly. We'll save the XML file and go to the activity. In the activity, we will create two edit text fields. One for name and the other for email address. We will instantiate these two edit text fields and map it to the edit text field in the XML file. Now we'll create a button object and map it with the button in the XML file. We will write a on-click listener for the button. We'll also create a text view object and map it with text view which we created for showing the data captured to the user. Now inside the onClick function, we will create a string called strname, which will get the text from the name edit text box and store it. Similarly, we'll create another string called str email, and we will be saving the text from the email edit text box. Now we'll set the text of the text view object which we created with the name and email address. We'll save the activity and run the application. The activity is launched and I enter a name in the first edit text box and enter an email address in the second text box. And I press enter. The data captured from these two edit text boxes is reflected in the text view below. Similarly, the data captured from these edit text boxes can be saved in variables and can be sent to server for any other additional functionalities. Creating other widgets. Under this topic, we will see the following headings: using image buttons, using checkboxes and toggle buttons, using radio buttons, creating a drop-down menu, using a progress bar, and using a seek bar. Let's see a demo of using image buttons. First, we'll create a new Android project and name the project. Select the build target and name the package. And press finish. Open the default activity which was created. We will edit the layout file of this activity. We will remove the text view which was already present inside the layout. We will add an image button and we will set the source as the launcher icon. We will add multiple image buttons. Now I'll go to the XML format of the file and edit the properties. The first button, we will set the background to be null. Similarly, the second button, we will set the scale type as fit XY. In the third button, we will set the scale type to be center crop and set the layout width to be 40 dp. The last button, we'll set the scale type to be fit XY and set the width to be 80 dp and height to be 40 dp. Now we'll view the graphical layout of the file. We will run the application. The activity is launched and we can see the 4 image buttons that we added to the layout. The first one doesn't have a background, while the second one has a background and it contains the launcher icon at the center of the button, whereas the third image button, we have restricted the width to be 40 dp and the scale type to be center crop, so the source image fits to the center of the button and the width is restricted. And the fifth button, we have set the width as 80 dp and height as 40 dp and the scale type to be fit XY, so the image which we used for the image button is stretched to occupy the width and height of the button. The image button behaves exactly the same way as button, except for the fact that it allows the user to add an image to the button rather than a text. Let's now see a demo of using checkboxes and toggle buttons. First, we'll create a new Android project and enter the project name. Then select the build target and name the package. And press finish. Now we'll open the project and select the default activity which was created. We will edit the layout file of this activity. We will remove the text view which was already present inside this layout. We will add a checkbox to the layout and add two other checkboxes as well. Then add two text views. We will edit the properties of these widgets in the XML format. We will edit the text value of these checkboxes to green, red, and blue. Similarly, we will edit the ID as well, just to remember the checkboxes correctly. We will edit the text of the first text view to be choice selections. And we'll go back to the demo activity. In the demo activity, we will create a text view object. In the onCreate method, we will instantiate the text view object and map it to the second text view which we created in the XML file. We will create a class called colors inside with Boolean variables for the three different colors. Now we will create an object of this class. We will also create a checkbox array. Which we will fill with the checkboxes which we created in the XML file. Now we will write set onClick listeners for each of these checkboxes. Inside the onClick function, we will check the state of the checkbox. We need to typecast the view parameter in the onClick function. If the checkbox is checked, we will set the value of the green color boolean value to be true. Else we will set it to be false. And we will set the text view text with the values of the boolean variables. Similarly, we will copy and paste the on-click listeners for the other two checkboxes as well. We'll save the file and run the application. The application is launched. They click on the green checkbox and we can see the values to be true, false and false. I click on the red checkbox and the text view is updated to true, true and false. And I click on the blue checkbox and all the boolean values change to be true. Now I click on the red checkbox again and the value is changed again to false. Thus, checkboxes can be used in Android applications for capturing boolean flags. Now we will edit the same code to use toggle buttons instead of checkboxes. Select the layout file and change the type of checkboxes to toggle buttons. Also edit the values in the XML file. Toggle buttons have text off and text on properties. Save the XML file and go to the activity. In the activity, change the checkbox array type to be toggle button and also change the typecast class to be toggle button. Now run the application. The application is launched and the toggle button states are off. When I click on the no green toggle button, it changes to green and it is checked, so the boolean value changes to true. Similarly, I click on the red and blue buttons and the boolean values change to true and their text also changed to red and blue respectively. Now I click on the red toggle button again and the value changes to no red and the boolean value changes to false. We will now see a demo of using radio buttons. First, we'll create a new Android project and name the project as radio button demo. Select the build target and name the package. Open the default activity which was created. Now we will edit the layout file of this activity. Click on the text view which was already present inside the layout. Delete it and add a radio group to the layout. Now edit the individual radio buttons to have the required text. And save the XML file. Now we will run our application. The application is launched and we can see our 3 radio buttons. The first radio button is selected. Now I select the second radio button. The red radio button gets deselected and the green radio button gets selected. Similarly, when I click on the blue radio button, the green radio button gets deselected and the blue radio button gets selected. Thus, a radio group with multiple radio buttons can be used to get a single value from a group of values. Now we'll see a demo of creating a drop-down menu in Android. First, we'll create a new Android project. We'll name the project as Spinner Demo. Select the build target and name the package. Now we'll open the project and select the default activity which was created. We will edit the layout file of this activity. We will remove the text view which was already present inside the layout. We will add a spinner to the layout and edit its ID to be spinner underscore color. We will save the XML file and return to the demo activity. Inside the demo activity, we will create a string array. We will have an array of colors. Now inside the onCreate method, we will create a spinner object and map it to the spinner we created in the XML file. We will create a new array adapter of type string which requires the context as the first parameter. Layout of the spinner item as the second parameter. And the array as the third parameter. Then we will call the set adapter function on the spinner object. Now we will run our application. The application is launched and we can see our spinner at the top of the layout. I click on the spinner and I get 4 values shown in a list. I select one of the values and is updated in the spinner. Now we will see a demo of using a progress bar. First, we will create a new Android project. We'll name the project. Select the build target and name the package. We'll open the default activity which was created. We will edit the layout file of this activity. We will remove the text view which was already present inside the activity, and we will add a progress bar. We'll make it to fit the parent, and we will set the gravity of the linear layer to be center and padding to be 4 dp, and we will add a button to the layout, and we will edit the properties of the button and state it as increase progress bar, and we'll set the margin top to be 20 dp, and we'll save the XML file. We will return to the activity. In the activity, we will create a progress bar field. We will instantiate the progress bar and map it to the progress bar we created in the XML file. We will also create a button object and map it to the button we created in the XML file. We will write a set onClick listener function for the button. And inside the onClick function, we will write the necessary code to increment the progress bar. We will also create a field called progress, and we will set to 0. Before setting the onClick listener, we will set the progress bar's initial progress. We will use the progress bar object and call the setProgress method and set it with the progress value, that is 0 initially. And inside the onClick function, we will increment the counter by 10 values. So the progress is incremented by 10 units, and then again we will call the progress bar dot set progress method and assign the new progress value. Now we will run our application. The activity is launched and we can see the progress bar and the button. The progress bar shows 0 progress at this moment. Now I press the increase progress bar button and the value is increased to 10%, and I press it again and the progress bar keeps on increasing as I click the progress bar button. This progress bar can be used when downloading applications or running a complex operation in the background and show the progress to the user. Let's now see a demo of using a seek bar. First, we'll create a new Android project and set the project name. Select the build target and name the package. We'll open the default activity which was created. We will edit the layout file of this activity. We will remove the text view which was already present inside the layout. We will add a seek bar to the layout. We'll go to the XML format of this layout and edit the properties. We will change the gravity of the linear layout to be center. We'll also set a padding of 10 dp. We will add a text view to the layout and we will edit the text to be seek value. Now we will save the XML file and go to the demo activity. In the demo activity, we will create a text view field. We will instantiate the text view field and assign with the text view we created in the XML file. We will create a seek bar object and map it with the seek bar we created in the XML file. We will set a on seek bar change listener for the seek bar. And inside the on progress change method, we will get the value of the progress and assign it to the text view which we created initially. We'll save the activity and run our application. The application is launched and we can see the seek bar and the text view which we added to the layout. Now I change the value of the seek bar and we can see the value updating in the text view. This seek bar can be used in forms where a value needs to be obtained from the user. Using resources. Under this heading, we will be seeing the following topics: supporting resource types, referencing resources in Java, defining views and layouts through XML resources, externalizing values, providing animations, and exploring the Android manifest file. Application resources such as images and strings should always be externalized from code so that they can be maintained independently. Alternative resources for specific device configurations should always be provided by grouping them in specially named resource directories. Once application resources are externalized, they can be accessed using resource IDs that are generated in the project's R class. The R.class file cannot be modified by the user, it's auto-generated. Even if the user tries to edit or delete the R class file, it will be auto-generated again. Supporting resource types. Animation resources. These define predetermined animations. Tween animations are saved in resources anim and accessed from the R.anim class. Frame animations are saved in resources drawable and accessed from the R.drawable class. Color state list resource defines a color resource that changes based on the view state, saved in resources color folder and accessed from the R.color class. Drawable resources define various graphics with bitmaps or XML, saved in resources drawable folder and accessed from the R.drawable class. Layout resource define the layout for your application UI. It's saved in resources layout folder and accessed from the R.layout.class. Menu resource. They define the contents of application menus, saved in resources menu folder and accessed from the R.menu class. String resources. They define strings, string arrays, and plurals, and they are saved in resources values folder and accessed from the r.string, r.array, and r.plural classes. Style resource. They define the look and format for UI elements. They are saved in resources value folder and accessed from the r.style class. More resource types. They define values such as booleans, integers, dimensions, colors, and other arrays. They are saved in resources values folder, but each accessed from unique R subclass such as r.bool, r.integer, or r.diamond. Referencing resources in Java. Once a resource is provided in an application, it can be applied by referencing its resource ID. All resource IDs are defined in the project's R class, which is automatically generated by the AAPT tool in the SDK. When the application is compiled, AAPT generates the R class, which contains resource IDs for all the resources in the resource directory. For each type of resource, there is an R subclass. For instance, r.drawable for all drawable resources, and for each resource of that type there is a static integer. For example, r.drawable.icon. This integer is the resource ID that should be used to retrieve the resource. A resource ID is always composed of the following things. The resource type. Each resource is grouped into a type such as a string, drawable, and layout. The resource name, which is either the file name excluding the extension or the value in the XML Android color name attribute if the resource is a simple value, such as a string. There are two ways one can access a resource: in code or in XML. In code, using a static integer from a subclass of the R class, such as r.string.hello. String is the resource type and hello is the resource name. There are many Android APIs that can access the resources when one provides a resource ID in this format. In XML, using a special XML syntax that also corresponds to the resource ID defined in the r.class file, such as @string/hello. String is the resource type and hello is the resource name. Let's now see a demo of defining views and layouts through XML resources in Android. First, we create a new Android project and name the project as View Layout Demo. Select the build target and name the package. Open the project. Select the default activity which was created. Here, in the onCreate method, we load the content using the setContentView method, and this method takes a parameter of layout ID. This layout is the externalized layout in the layout folder. It's referenced by the file name without the extension. Click on the layout file and you can see a text view in the layout file. Now I can drag and drop a button inside the layout or a text field inside the layout and edit its properties. Every widget inside a layout can be assigned with an ID. Now back in the demo activity, I can create a edit text object and instantiate by using the constructor. but this creates a new edit text object programmatically. Instead, if I want to map the edit text object which we created in the XML file, then I can use the following syntax. Use the find by view ID method and pass the ID of the edit text which we created there. You should also take care that we typecast the widget before assigning it to the variable. Similarly, I can create a button object and assign it to the button object we created in the XML file. This provides an advantage to the developer by separating the UI and the business logic. The UI can be designed separately and the business logic can be coded separately, and then they can be mapped together using this method. Providing animations. The Android framework provides two animation systems: property animation and view animation. There is also drawable animation, which allows to load drawable resources and display them one frame after another. The view animation system provides the capability to only animate view objects. Another disadvantage of the view animation system is that it only modifies where the view was drawn and not the actual view itself. With the property animation system, these constraints are completely removed, and any property of any object can be animated and the object itself is actually modified. Exploring the Android manifest file. Let's now look at the various tags present inside an Android manifest file in an alphabetical order. Action. It defines the action. Activity. It defines an activity used inside the application. Activity alias. It gives an alias name to the activity. Application. It defines an application, class name, label, icon, or theme, and it exists only one per manifest. Category. It defines an intent category. Data. It defines an intent MIME type, URI scheme, URI authority, or URI path. Grant URI permission. Instrumentation. Declares a test instrumentation component. Intent filter. It declares the intents and activity supports. Manifest. Defines application package and Android namespace. Metadata. General metadata accessible via component info metadata. Permission. Declares a security permission. Permission group, permission tree. Provider. Defines a content provider to manage persistent data for access by other applications. Receiver. Defines an intent receiver, responds to intents, also supports intent filter. Service. Defines a background service and also supports interfilter. Support screens. Mentions the screens that are supported by the application. Uses configuration. Mentions the configuration used by the application. Uses feature. Mentions the features used by the application. Uses library. Mentions the third-party libraries used by the application. Uses permission. Requests a security permission. And uses SDK. Mentions the SDK the application uses. User interface events. Under this heading, we will see the following topics: intercepting a physical key press, building menus, defining menus in XML, utilizing the search key, reacting to touch events, listening for fling gestures, and using multi-touch. Intercepting a physical key press. Physical key press can be detected by overriding on-key-down method or on-key-up method. The arguments contain the key code and the event that triggered the method. Other methods include on-key long press, on-key multiple, on trackball event, or on backpressed. Let's now see a demo of intercepting a physical key press. First, we'll create a new Android project and name the project as Intercept Key Demo. We'll select the build target and name the package. We'll open the default activity which was created. We will override the on key down method. We will create a switch case statement inside the method, and we will pass the key code to the switch, and for the case statement we will use constants from the key event class. We will add a toast value if it is a D-pad left key. Similarly, we'll copy and paste the same case statement around 2 more times, and we will change the key code type as D-pad right, and D-pad center. We will also change the toast values. We will also override the on back press method. We'll remove the super.on backpress method. It will be finishing this activity, so we will override to show a toast that the back button is pressed. We will also override the on key up method, and we will check if the key is the search key. If the key code matches the search button, then we'll show a text that the user pressed the search button. And we'll set the toast duration as long. We'll save the file and run the application. The application is launched. Now I will press the D-pad left key and we get the toast, and I press the D-pad up, but since we have not traced that in the switch case block, we don't get any toast. I press the D-pad center and we get the toast message. I press the back button and we get a message that the back button is pressed. This key intercepts can be monitored for performing any function in the application. Building menus. Menus are an important part of an activity's user interface that provides a familiar way to perform actions. Android offers a simple framework to add standard menus to an application. There are three types of application menus. Options menu, the primary collection of menu items for an activity which appears when the user touches the menu button. The context menu, a floating list of menu items that appears when the user touches and holds a view that's registered to provide a context menu. Submenu, a floating list of menu items that appear when the user touches a menu item that contains a nested menu. Building menu, the steps involved in building a menu are: creating a menu resource, define a menu in an external XML file, inflating a menu resource, inflating the menu from the external XML file, done by overriding onCreateOptions menu and onCreateContextMenu methods, handling the events on the menu, done by overriding onOptionsItemSelected and onContextItemSelected methods respectively. Utilizing the search key. Any search function can be mapped to the search key. The event can be monitored by overriding the onSearchRequested method. Care should be taken to add the functionality in other menu, as all devices in the market don't have the search key. Reacting to touch events. Touch events can be detected by implementing the following interfaces and overriding its corresponding methods. OnClick from view.onClickListener. This is called when the user touches the item. OnLongClick from view.onLongClickListener. This is called when the user touches and holds the item. OnTouch from view.onTouchListener. This is called when the user performs an action qualified as a touch event, including a press, a release, or any movement gesture on the screen. OnCreateContextMenu from view.onCreateContextMenuListener. This is called when a context menu is being built. Let's now see a demo of reacting to touch events. First, we'll create a new Android project and name the project as Touch Demo. We'll select the build target and name the package. We'll open the default activity which was created. We will edit the layout file of this activity. We will remove the text view which was already present inside the layout. We will add a button to the layout. We will change the text as Press Me. We will save the XML file and go back to the demo activity. Inside the onCreate method of the demo activity, we will create a button object. and map it to the button we created in the XML file. We will write a set onClick listener function for the button. Inside the onClick function of the button, we will write a toast and we'll show the message that button was clicked and the toast duration as long. Now we'll set a on long click listener for the button. And set the return type to be true, and inside the on long click function we will again create a toast and this time around we will show the message that the button was long clicked, and we will set the duration to be long. Now we'll run our application. The application is launched and I click on the press me button. The toast is shown as button was clicked. Now I long click the button and now I get a toast that the button was long clicked. Thus, touch events can be used on various widgets in Android to perform many functions. Now we will see a demo of listening for flink gestures in Android. First, we will create a new Android project. We will name the project, select the build target, name the package, and press finish. Now we'll open the default activity which was created. We will edit the layout file of this activity. Remove the text view which was already present inside the activity and add a large text view inside the layout. Go to the XML format and edit its properties. Remove the text which was present inside the text view and save the XML file. Now going back to the demo activity, create a static variable and assign the value 60 for the variable. Create a field of class type gesture detector Also create a field of object type text view. Instantiate the text view object inside the onCreate method and map it to the text view you created in the XML file. Also instantiate the gesture detector object using the constructor. Create a new simple on gesture listener and define its methods. Override the onFling method. Inside the onFling method of the simple on gesture listener, check the following conditions and append the respective text to the text view.